Hello, my name is Dr. Simon Schmidt from the Fraunhofer Institute for Building Physics IBP. I welcome you to the fourth video of the sixth modules where we discuss the measurements of the hygrothermal properties. In the previous sub-modules, you have learned about the construction, the heat and moisture transport, and the energy efficiency of the construction in AGARTALA. Today, we will have a look at the durability of the construction by evaluating the hygrothermal properties of construction materials using measurements. Just as the thermal parameters of a building material must be investigated, it is also essential for simulations to determine the hygrothermal parameters of a building material. If they are not available from the producers, the only way to get them is by using measurements in the laboratory. For this purpose, there are various tests available, investigating both the sorptive and the drying behavior of building materials. In the following, I would like to present the most common methods. The first test I would like to show is the so-called dry and wet cup test. This test is for the evaluation of the vapor diffusion through a material. The result of this test is the vapor diffusion resistance coefficient, which is used to evaluate one part of the wetting and drying out of constructions by using simulations in order to evaluate the durability of the construction. For this test, the material examples, mostly 10 by 10 centimeters, have to be prepared and then set into a climate chamber with different temperatures and moisture content. To measure the vapor transport, the samples are weighed at regular intervals and the increase or decrease in weight is recorded. Using this, the change in weight, the diffusion can be calculated. As mentioned, this has to be done in a special climate chamber, in which the boundary conditions have to be kept precisely constant. This is measured by a thermohygrometer, as you can see it on the left of the picture. But now, let us take a look at the test itself on the next slides. As mentioned, the wet and dry cup test is to determine the vapor diffusion through a test material. As you can see here, the test comprises of two parts actually. This is due to the fact that vapor diffusion is dependent on the vapor content in the test material. Therefore, one wet cup test and one dry cup test is performed. In the wet cup test, the material sample is densely applied to a glass vessel with paraffin. The paraffin sealing is just at the vertical parts of the test material, preventing the vapor to take the shortcut, but has to go vertically through the material. For the wet cup test, the glass vessel contains a special solution that generates a humidity of 90% in the vessel. By regular weighting, it is possible to measure the amount of water diffused through the material into the climate chamber. The preparation of the material for the dry cup test is the same as with the wet cup test. But in the dry cup test, the vessel is filled with silica balls. These bind all humidity in the vessel and therefore create an atmosphere with 2 to 5% relative humidity within. By regular weighting, it is possible to measure how much humidity has diffused from the climate chamber through the test material into the vessel. So the direction of the vapor flow is from the inside to the outside for the wet cup test, and from the outside to the inside at the dry cup test. By combining both, some calculation, the water vapor diffusion resistance coefficient can be calculated, which in the end will become one number. For concrete, for example, this coefficient is 180. But now let us have a look at another test method we are using to evaluate the water uptake from a material. Also, this test gives us insight into the material properties regarding the water transport which we need to evaluate the durability of a construction. As the dry and wet cup test before, this test is performed in order to test the sorption properties of a building material. This means now we are looking at the fluid water uptake in contrast to the vapor transport before. Both play a major role in the calculation of the water content of building components in the construction. But let us have a look at the measurement itself. In order to perform this test, a building material sample has to be cured to its balancing moisture point at the climate chamber in which the test is performed. After this, the sample is placed in a water basin with a defined water level height and sits there for some time. At defined time intervals, the sample is taken out of the basin, weight, then increase in mass is noted down and evaluated in the end. Out of these measurements, the liquid transport coefficient, in short, W value, is calculated. As this value is as highly dependent on the water content of the sample, we do not calculate a single number, but a coefficient depending course. But let us have a closer look. In this picture, you see a brick, which is to be set into the water basin. The tests in the picture were done with bricks, as they show the effect of sorption quite well. But the measurements of a similar concrete test sample, like it is used in AGARTALA, would be the same. In this picture, you can clearly see which area of the stone which is saturated with water already. In this experiment, the saturated area may well be higher than the water level in the basin. Capillaries in the building material can cause the liquid to be sucked into the building material and thus leading to moisture penetration. Now let us have a look at a sketch of the test. What was shown in the picture was that, unlike the aforementioned test, the brick is covered in paraffin on the vertical areas in order to prevent the water from taking the short track. The sample is put into the water and the water is taken up into the sample. By weighting the sample regularly, it is possible to determine how great the absorbency of a material is. In addition, it can be measured how high the water in the building material has risen by sorption. With this, we can recalculate the water uptake in a construction, for example, after rain events. Summing up these measurements, we have seen how to evaluate the water vapor diffusion resistance coefficient. We also call it mu value, by performing the dry and wet cup tests, and the liquid transport coefficient. We also call it W value. With the performances of these tests, we have now the relevant parameters at hand for an hygrothermal simulation in order to evaluate the durability of a construction. But without these measurements, this is not possible. So let me sum this up. Measurements are necessary before evaluating balances and simulations can be performed. Various methods are available in order to measure the properties of materials and components, of which we just have seen two in this lecture. But we need them if we want to quantify forecast, as we need the hygrothermal parameters for new materials and have to use the different measuring methods in order to gain insight into all the aspects we need to evaluate for durability of our future construction. And with this, I would like to say thank you and goodbye until the next video.